Hello, is this thing? Oh, hi, I'm Andrew. Today I'd like to teach you how to find the slant asymptote of the following rational function of 81x squared minus 18 divided by 3x minus 2. So whenever you have a rational function, which is just a technical way of saying that you have a polynomial function divided by a polynomial function, which is just kind of a complex way of saying you got some variable up here, maybe some variable down here. Anytime the highest power of your variable in the numerator, in this case it's a 2, is being divided by then a polynomial function where the highest power of that variable in the denominator is less than 2, you'll always have a slant asymptote. Now, how do we do this? Well, turns out we got to set up a long division. Let's take a look. Bam. So basically the numerator here goes inside of that long division symbol and the denominator goes on the outside. All right, now anytime you got to find the slant asymptote, you're always going to do a long division. You might be able to do a synthetic division also, but that you can only do the synthetic division if your highest power of x here is going to be to the first. All right, if it's to the second, this thing goes out the window. But if it was to the second, then this would have to go to the third. All right, so this is probably the best way. This is probably the best way to do it. Now, what you're going to do when you do your long division, you're going to look inside of your long division symbol, basically your numerator. You're going to locate the highest power of x with its coefficient, write it down. Then you're going to divide it by the highest power of x with its coefficient from your denominator, which was 3x. And you're just going to do this division, right? So you have to figure out how many times does 3 go into 81. So if you're not sure, just take out the calculator, do 81 divided by 3, and there you get 27. Cool? And then x divided into x squared is just simply x. So you're going to take this value, which is part of the quotient, and you're going to put it on the top. It doesn't matter where it goes. Just put it on the top. Then what you're going to do is you're going to set up your subtraction thingamajiggy, and that is the technical term in case you were wondering. And you're going to take the 27x now, you're going to multiply it by each of the terms there of your original denominator. So 27x times 3x is going to be 81x squared. Now, if you did that correctly, it should exactly match what you have here. And then you're going to take the 27x and multiply it by the negative 2. So that's going to be a negative, and that works out to be 54x. Okay? Now, there's no, this second term, third term, however many terms you have, there's no guarantee that anything will match at that point. All right? But what you're going to do now before you do any subtractions or additions, you're going to distribute that negative sign to each of the terms inside of that parentheses. So the 81 basically becomes negative, and the 54x will become positive. All right? Now do your addition and subtraction. So these two terms just cancel out beautifully. One's being subtracted from the other. And these terms don't even combine. You can't combine 54x with 18, right? There's no x there. So you're just going to write 54x, okay, minus 18. Now you would be done with your long division if the term here that remains has a power of x that is less than the power of x in your original denominator. But it doesn't. It's equal to. All right, they're both 1. So you're going to continue the process. Same thing. You're going to take your highest power of x there, which is 54x, and you're going to divide it by the 3x, okay, the highest power of x in your original denominator. Right, and if you're not sure, just go 54 divided by 3. There you go, 18. Okay, and then x divided by x is just 1. So this is just an 18. So you're going to take this term and now add it, because it's positive, to the quotient up there. Then same thing, set up your subtraction thingamajiggy, take that 18, multiply it by each of those two terms. So that should be a 54x then. And then 18 times the negative 2 should be negative 36. Okay, and now what you're going to do is you're going to take these this negative sign and distribute it to each of those two terms, right? So the first one becomes negative, the second one becomes positive. Great. And the 54x's just go bye-bye, and then you have got a positive 6 minus 18, basically, which is just going to be a positive 18. So this is now the remainder, since there's no more power of x, or, you know, the x is really to the 0 power down here, and since it's less than the first, you're done. Okay, this is the remainder now. So you don't even need this at this point, but I'm just going to write it down. You take the remainder and you put it over your divisor there, or the original denominator. All right, 3x minus 2. So when you're finding the slant asymptote, though, you're looking at the meat of this function. In other words, you're this thing. Okay, it does not matter. I don't care what the remainder is. So it's basically everything except the remainder. All right, when you do the long division. So this is going to be your slant asymptote. Now notice how it is a linear line because it just has x to the first power, and that's that. Now if you want to kind of see this, right, you can always graph it. So go to your graph, go to your calculator, and type in the original function. So open parentheses, do 81x squared minus 18. Okay, close those parentheses, then hit divided by, open the parentheses again, do 3x minus 2. If you don't have the parentheses in here, it's not going to come out right. Hit graph. Okay, so I got part of my function here. Maybe there's something going on up at the top, so why don't I adjust my window a little bit. I'm going to bring in the x's a little bit because I noticed that there's a lot of variability there, and maybe I'll go up to 100. I don't really know where it is, and I could figure it out, but I don't really want to spend time. But there you go. Okay, so here we kind of see it, and we kind of see that slant asymptote right along this little slant. So all you got to do now, watch, just plug in now that slant asymptote that we said, 27x plus 18, and let's see what happens. Huh! Look at that. Right? Look at this. Isn't that so nice? You can see this function now approaching that slant asymptote both sides. And that's all there is to it, ladies and gentlemen. Okay? So everyone, thank you so much for tuning in. We really, truly want to help you through your class. We have thousands of videos out there to help support you through your studies, not only in mathematics, but chemistry and physics as well. We have a lot more coming out. We're also going to, over time, leave a lot of goodies down there in the description below just to help you through your class. All right? You're not alone. It's kind of daunting when you have a lot of material, but the best way to do well through your class is to do a ton of practice. Actual problems. Okay? And we have your back. Not only do we have the solution, but we're going to explain the logic behind how to do it. Check us out. See ya.